All right, we're back from the intermission. Hope you enjoyed. All right, percent error. The percent error is the percent, the absolute error is, of the exact value. And here is our little formula we're going to use. A minus x with the absolute value around it divided by the absolute value of x times 100. Multiplying by the 100 is what will make it the percent. Where x is the exact value of the quantity and A is an approximate value of the quantity. So once again, A minus x absolute value divided by the absolute value of x times 100, where x is the exact value of the quantity and A is an approximate value of the quantity. Find the percent error for Taylor's measurement 1. What does this mean? Okay, so we're going to go look back up at Taylor's measurement 1, which was, if you look on the front side, 15 2/8 inches. So if we find the percent error for Taylor's measurement 1, what we're going to need to do is do the absolute value of A minus x. Well, if we remember from the front, A is the approximate value, right there. So that means we're going to do 15 2/8 minus x, where x, don't forget from the front, is the exact value. Well, the exact value was 15, divided by the absolute value of the exact value, 15, times 100. Okay, so we're going to say, we already did this on the front. We were left with 0.25 when we did 15 2/8 minus 15 over the absolute value of 15 times 100. Now the absolute value of 0.25 is 0.25. Absolute value of 15 is 15, and we're going to multiply by 100. All right, well, I like to do a little bit of the math in my head. So if I take this decimal point and move it over 2, so it becomes a 25, then that means I have to move my decimal place in the denominator over 2. So this becomes 1,500 times 100. You also would be more than welcome to put 0.25 divided by 15 times 100 into your calculator. So that means the zeros will cancel out here because it's like 100 over 1, so you can cancel out the zeros. So you're left with 25 divided by 15. Once again, I can simplify it by dividing both by 5, which is 5/3. So that's equal to 1 2/3%. And the reason that this is a percent is because we multiplied it by 100. It says, what does this mean? Well, that means that Taylor's measurement 1 is 1 2/3%, or it has an error that is 1 2/3% of the actual value. So her measurement has an error, that is 1 2/3% of the actual value. That's what Taylor's measurement 1 is. She has an error that is 1 2/3% of the actual value. Well, what about Connor's measurement 2? Okay, Connor's measurement 2 from the front side is 14 7/8 inches. minus the actual divided by the absolute value of the actual. Both have the absolute value times 100. Once again, we already did this, and it turned out to be negative 0.125 and 15. The absolute value of each is 0.125 and 15, because that's the distance from 0 times 100. All right, once again, I'm going to move my decimal place, so I have 125. I just moved it over 3. Well, that means I have to add some zeros and move this over 3. Over 15,000 times 100. All right, I'm going to cancel out these zeros. So I'm left with 125 divided by 150. Well, 25 can go into both. So I'm left with 5/6%. I'll wait a second so that you guys can catch up. This one, once again, is going to ask, what does it mean? Well, this time what it means is Connor's measurement 2 has an error that is 5/6% of the actual value. This one has an error that is 5/6% of the actual value. I'll move my hand in 1 second so you guys can write it if you'd like. An error that is 5/6% of the actual value. So it's going to ask us next, what is the purpose of finding percent error? Why do we need percent error? Well, it tells you how big your error is compared to the true value. It tells you how big your error is compared to the true value. I think that this is also important because it tells you a lot too in a profession that you're in. For example, well, here's the first one that comes to my mind. If we're talking about the distance for a marathon, well, you know, an error of 1 centimeter would be super small when you're measuring the distance for a marathon. If you made the finish line just 1 centimeter too small or too big, wouldn't be that big of a deal. This is where I was talking about with your jobs. If you had an error of 1 centimeter, if you were a heart surgeon, that would be a very, very large error and be a big problem. So in evaluating the seriousness of an error, we usually compare it to the exact value. All right, 2 more examples. Kayla's class went on a field trip to an aquarium. One tank had 30 clownfish. She miscounted the total number of clownfish in the tank and recorded it as 24 fish. What is the percent error? So we're going to take the absolute value of what she approximated, which was 24, and subtract the actual amount and put the absolute value around it. And then we divide it by the actual amount with the absolute value, times 100. 24 minus 30 is a -6. The absolute value of -6 is 6 because it's 6 away from 0. And the absolute value of 30 is 30 because it's 30 away from 0, times 100. Okay, I'm going to cancel out one of the zeros. Well, I can divide both 6 and 3 by 3. So this becomes a 1, and this becomes a 2. So I'm left with 2 times 10 is 20%. So what is Kayla's percent error? 20%. It's a pretty big percent error. All right, last one. The attendance at a musical event was counted several times. All counts were between 573 and 589. If the actual attendance number is between 573 and 589, inclusive, what is the most that the percent error could be? Explain your answer. So this one's a little bit trickier. We have to really think about it. Well, the most that the absolute error could be, if the actual attendance is somewhere in between here. Well, if the actual, let's say, was the 573, and your guess was 589, we have to assume it'd be the largest away from each other. So the most the absolute error could be is the absolute value of 589 minus 573. Well, that's just 16, and the absolute value of 16 is 16. This is just something to note so you understand what we're doing next. The percent error will be the largest when the exact value is smallest. So, the most the percent error could be, sorry about that. So the most the percent error could be oh my goodness. Big How's phone keeps going off. He's an important guy. Come on, Big How, you're gonna get an ODR for that phone in class. So the most the percent error could be is, all right, the percent error will be the largest when the exact value is the smallest. Well, that makes sense. Think about it. If we know that actual, or the most that the absolute error could be is 16. So that's what we did as our a minus x on the top of our numerator with the absolute value. Well, if I divide by a, sorry, I'm losing my train of thought here. Let me write this down first. If I were to divide by this number, the 573, the percent error will be larger. Think about when you divide by a number. If I were to divide by the 589, it would be smaller. Think about what happens when you divide. If you divided 1 divided by 2, that's a larger number than if you divide 1 divided by 3. So, we want to go with this number because it will give us the larger percent error. So, let's keep going. That's 16 over 573 times 100. All right, I'm okay with you guys plugging this one in your calculator. You're gonna get something like 2.79 going on. So let's just put 2.8 because the percent error is less than 2.8%. Remember back up at the top, what is the most the percent error could be? So it's got to be less than 2.8. And that makes sense because we rounded up. So it's definitely going to be less than 2.8. All right, guys, don't forget your 4-8 homework's due tomorrow, your warm-up's due tomorrow, and get problems 6, 7, and 8 done from the homework last night, the 4-5 and 4-6. Can't wait to see you guys back tomorrow.